All right, welcome back, peoples. So here I'm going to show you how to evaluate limits analytically. And I'm not going to waste your time with the theory and proof and the math, mumbo jumbo, because I'm a high school teacher and I know most high school kids just want to know how to do the math, which isn't a bad thing. It's actually a good thing in a way because they know exactly what they want to do and you'll use your time efficiently. But if you want to learn that other stuff, you got to go somewhere else. So let's just get going. So when you're evaluating limits analytically, there's really two main techniques. The first one is direct substitution. Let's try this first. If this doesn't work, then I'm going to show you the second one, but always try this first. No, not always, but try this first. So what does that mean? It means you substitute directly. Now, what does that mean? I'm going to show you with an example. So let's look at, okay. We're going to find these limits. So let's actually go over here. So example. A, B, C, D, E, F. A, we have the limit as x approaches C. X approaches C of, wait, hold on. X approaches, the limit of B as x approaches C is equal to, whoa, where am I? I'm over here. So what does this mean? Well, remember, this is just a number. Like, think of B as just like 10. So if you look at a graph of this, it's just like a horizontal line, y equals B. So if C is like some other number, like as x is going towards C, maybe C is like 5, it's just going to stay on this graph. So it's always going to be this B value. So like this would be C comma B. Again, if B is like 10, this would be like y equals 10. If C was like 3, this would be 3, 10. That's the whole idea. So this is equal to B. No, this is equal to C. No. As x approaches C. No, B, yeah, it is B. Duh. I was confusing you guys and myself as well. I don't like that red color. Next one. The limit of x as x approaches C. So the limit of x as x approaches C is equal to, okay, so this is a graph of a diagonal. So, I don't like this marker, turn that way. Switch. So this would be like a diagonal line, y equals x. So this line, remember, is the diagonal where x and y are both always the same. So this would be 1, 1, like whatever, 2, 2. X and y are always the same. So when x approaches C, this is also going to be C. Because whatever x is, this is, or y is. So don't overthink it. So if like x is like, if we're saying x approaches 2, it's going to be 2. Pretty simple. And these are become much more easier to understand when you're doing numbers. Hey. All right, next one. Oh, I gotta get another marker. C. This guy, C. The limit of x to the n as x approaches C. So this is now an exponential, or not exponential, this is a power one. Direct substitution, directly substitute C into n, or C into x. So this will be C to the n. All right, next one. D, we have, oh, it's over here too. The limit of 4x squared plus 3 as x approaches 2. So remember, it's called direct substitution because you directly substitute 2 into x. So 4 times 2 squared. 4 times 2 squared plus 3. 4 times 4 is 16 plus 3, 19. Yay! Got it. E. Go down low. Here we go. Oh, come on. E, we have the limit as x approaches 1 of x squared plus x plus 2. x squared plus x plus 2 over x plus 1. So substitute 1 in for x. Okay, so 1 plus 1 plus 2, so 4 over 2. Four over 2, so 2. All right, let's up with this box. There we go. I'll show them 2. All right, let's keep it going. F. Another mark. Here we have the limit of the square root of x squared plus 4 as x approaches 0. So substitute 0 in for x. So the square root of 0 plus 4 is the square root of 4. That is just 2. All right. Yeah, there we go. Simple. Let me get some water. A couple more, or one more, or 2 more. A couple more, like 4 more, 5, 6. 1, 2, 1, 2, 3, 4 more. Let's handle this. So let's erase these and do some other ones. And limits. I wish the word sounds really cool, but I wish the problems were cooler, but don't worry, calculus gets better after this. It can only get better. So G, well, it can't only get better, but it does. So G, we have the limit of the third root of 2x squared minus 10 as x approaches 3. So another direct substitution. So the third root of 2 times 3 squared minus 10, which is the square root of 2, or third root, 2 times 9, 18 minus 10. So 8, the third root of 8. The third root of 8. Which is 2, because 2 times 2 times 2 is 8. All right. What do we got next? H. The limit as x approaches 1 of x cubed minus 1 over x minus 1. So plug in 1. So we get 1 minus 1 over 1 minus 1. 0 over 0. Oh, shit, what the hell? No, I remember an elementary school teacher said not to. Actually, that's not be dramatic. We're cool here. So we get something that is not defined yet. We actually get something that's undefined. I wish they became more creative. So we have 0 over 0. So what do? Or we say this is an indeterminate form. Now that we're sophisticated, this is an indeterminate form. Now later on, you're going to learn how to deal with these using L'Hopital's rule, but sometimes you don't need it. So let's see what we can do. Now, and a paper. When you have stuff like this, we turn to our second strategy. Here I am. Which we just say, let me organize this. When this doesn't work, so let's just number 1. I should put number 1. So number 1, try number 1. Then if that doesn't work, then try number 2. Create a new function that's very similar to the original. A new function similar to the original. I don't know if I have to write it. I could probably just say it and you'll be good. similar to the original, except at that point. Except at that point, parentheses. So that point where you got, into big trouble with the 0 over 0. So except at 1. So what do we do? So for example, let's define this. Let's say f of x. What the heck is going on? So we're going to say f of x is this. X cubed minus 1 over x minus 1. So what we're going to do is make g of x equal to this, except we can actually cancel out the x minus 1. Let me zoom out a little bit. Can I? Oh, there we go. Where I am. So g of x could be, the top will be x minus 1 times an x squared. What did I do here? X squared plus x plus 1. If you multiply it out, you'll see that it does work. And we do that because, hey, these x minus 1s will cancel. And so then g of x is just equal to this x squared plus x and plus 1. This is what g of x is equal to. Whereas f of x is this. Oh, crap. Went down to the floor. This laptop's in the way. Now, we do this because we can plug in the 1 into this. So the limit as x approaches 1 of g of x is going to be equal to 1 plus 1 plus 1. 1 squared plus 1 plus 1, 2, 3. So it's going to be this as our answer. Now, what's going on graphically is, let's see what my graph is. Where did I put it? Oh yeah, so it's that funky graph where it's let's do it over here. Actually, let's do it up here because I don't want to bend or hunch down because I may need to draw 2 graphs. All right, this is important, so pay attention because your math life may depend on it, which is a good thing because then your life is important. Okay, so f of x is this, and it looks like the parabola thing. So this is f of x, and this has a hole at 1, 3. It's an open circle. G of x is just like this, except it has a closed circle at 1, 3. That's the only difference. So actually, let me go back and draw another graph. So on another grid, another space-time, or another universe, draw g of x, just like that, g, except there's a closed circle at 1, 3. That's it. That's the only difference, because we can actually find the limit. So we actually remove it. We remove the discontinuity. So this is a removable discontinuity. Discontinuity. It's a really cool word, so make sure you love it and have passion when you say it. Discontinuity. We remove it. It's removable. Now let's do 1 or 2 or 3 more. Let's do H. No, we did H. Let's do I and J. All right. Yeah, that's a great case. We already have these done. So where were we? I. So we have I. So we have the limit as x approaches -3 of x squared plus x minus 6 over x plus 3. All right. Okay, so if we were to plug in -3 into here, you would get 9 minus. So if we use direct substitution, we would get 9 minus 3 minus 6 over -3 plus 3. See, we would get 0 over 0 again. Which is not good. We get another undefined value, which is going to cause all sorts of problems. It's stress us out. We won't be able to sleep, and we'll be having night sweats. We'll be like, waking up all red-eyed, bug-eyed. People are going to think we're like smoking crack. We're really just because we can't solve it, blah, blah, blah. But make sure you take care of this before it destroys your life. Now, because you want to enhance your life. So we use our technique of factoring that out. So let's make f of x equal to this. X squared plus x minus 6 over x plus 3. And we'll make g of x equal to x squared plus, well, let's actually use this. X plus 3 times x minus 2. Because we can cancel those out and we just get x minus 2 as our g of x. So now what we have, okay, so then if we take the limit as x approaches -3 of g of x, this will just be -3 minus 2, which will be -5. Yeah, that's right. So we have an answer. So what's going on here is that same idea as the one before. We draw our two graphs. Uno, dos. Over here, we're going to have f of x. So f of x will be like this. What would it be? A line like this. This is f of x. And at -3, we have an open circle at -3, -5. That's what's going on here. We have an open circle here. That's our discontinuity on f of x. But for g of x, exactly the same, except at -3, -5, we have a closed circle. Closed. So we include it, and we're good. And our graph is continuous everywhere. Yay! Hooray! Yeah. So this is another removal of discontinuity because we removed it. See, we took it out, and bang, put a new one, or not a new one. It was never there. All right, one more. All right, this is a big one. This is really the only other type of problem you'll get on your AP exam, where you gotta know how to multiply by the conjugate. Let's do this. Okay, so try to erase. No, yes, erase it all. Okay, destroy it all. One more. Come on. You can do it. Okay, so find the limits. As x approaches 0 of the square root of x plus 1 minus 1 over x. Now, see, when you plug in 0, you're going to get the square root of 1 minus 1, so 0 over 0 again. That's not good, and we can't just remove it by the factoring. So what do? We use rationalization by doing some other stuff, actually not called what we do, but we multiply by the conjugate. Multiply by the conjugate. Maybe I'll use the right hand. Multiply by the conjugate. Multiply by the conjugate. You know, like conjugate visitations? Maybe you don't know, actually. Never mind. Conjugate. Okay, so here's the original guy. So what we're going to do is, actually, we're going to have the square root of x plus 1 minus 1 on top over x. Here we're going to multiply. See on here we have, let's go all red. So on top we have still the square root of x plus 1. But instead of minus, we do plus 1 out here. Yeah. All over x still. No, we do the same over the same thing because we have to make it equal to 1. Because again, we're multiplying by 1. This whole thing is just equal to 1. Same thing over same thing is equal to 1. Okay, now we do this because the magic starts to happen. Using distribution, we'll just work it out. So x, this times that. Where should I go? Let's just go down below. The square roots will go away, so you'll get x plus 1. And then we do this times 1, so plus the square root of x plus 1. Then you do this times that, so we do minus the square root of x plus 1. And minus 1 times positive 1, so minus 1, all up on top. All over this times that. So x times, and we leave this, just leave it there, don't mess with it. This is going to cause a problem, so we leave it as is. Because you're going to see that this cancels, 1 minus the 1 cancels, and we just got an x on top. So I'm going to erase this guy, it's going to go away. Come on. And we'll get x, let's put it in parentheses, emphasize it, over x, parentheses again in red, the square root of x plus 1 in the bottom. What's in the bottom? These cancel. Yay. Not like cancel culture, in a cool way. In the bottom, we got square root of x plus 1 plus 1. All right, so then, see? Now we're ready to throw in the limit. Let's do it. Now it's ready to handle it. It's trained, it's in shape now. It can take it. Before it wasn't in shape. It had to go through years of rigorous training before it can take this limit. Now we plug in 0 into here. So the limit of 1 over the square root of x plus, what is going on? I'm out of the erasers. I gotta use a shirt. Yeah. Throw that 0 into here. So 1 over square root of 0 plus 1. So 1 over the square root of 1 plus 1. And we get this 1 over the square root of 1 plus 1, 1 over 2. So 1 over 2 is our answer, 1/2. All right. Good job, Odie. All right, good job, guys. Really proud of you. I'm going to sleep now. Oh, over here. I'm going to sleep now. Well, I was sleeping. Okay. Thanks, guys. I have to use the bathroom, so hope that helps. Subscribe. Bye.